Today we're going to discuss something called a one-sample T interval. And that's important today, that we're going to be talking about something called a T interval. And that's because sigma is unknown. We do not know the population standard deviation in this question. So it turns out to be very similar to the one-sample Z interval, just like the one-sample t-test is very close to the one-sample z-test. The confidence interval's basic format looks like this. It's x bar plus or minus t star times s of x over the square root of n. So you'll notice that looks just like the interval in the previous video when we talked about a z interval. And in a z interval, you had x bar plus or minus z star times sigma of x over the square root of n. So what we're doing in a t interval case is we're using s of x, and we kind of hope that it's close to the population standard deviation, even though there's really no way to know that. Okay, let's get to work. We read this question. It's about a car and the gas mileage readings from the computer. What you have here in the middle is a list of all the readings that the computer produced, and we're supposed to compute a 95% confidence interval. So just like a z-test, it starts off with assumptions. So number one, you're supposed to pick an SRS of all the possible readings from the computer. Number two is to check for independence. And that means that the population of all readings has to be greater or equal to 10 times our sample size, which in this case is 20. So you get 10 times 20 or 200. So we just have to assume that. And since this is working, then we know that s of x bar is equal to s of x over the square root of n. So you need to go do one variable statistics for this in your calculator. S of x turns out to be 3.116 over the square root of 20. That needs to be divided. While we're at it, we'll also make note of x bar. X bar turned out to be 18.43. And then getting back to this standard deviation, when computed, this turns out really about 0.7 is what you end up with. So let's leave it at that. Okay, and then lastly, you had to check for normality. You need a sample size to be big enough. Supposedly, we would really like n to be greater than or equal to 30, but that didn't happen in this question. N was only 20. So that means you got to check a box plot. The box plot for this, well, I'll show you what it looks like, give you a sense. It doesn't look too bad. It's got just a little bit of skewness. It's got a very large interquartile range, so the middle box looks kind of big, but the tails are kind of short. But anyway, this is roughly symmetric. There's no outliers present, so it's safe to use the T procedures. So that's the note we would make. It's safe to use the T procedures. So let's go fill out what we can in that confidence interval. If we look at the basic format of it, here it is. We have most of the pieces. We said that x bar was 18.43 plus or minus. We'll leave t star out for now. And we had said in the previous page over here that 3.116 over the square root of 20 was s of x bar, which turned out to be 0.7. So I could put that in over here times 0.7. And the thing that's left to do is figure out t star. So we want a 95% confidence interval. You have to remember the t distribution changes according to degrees of freedom. So make a note of what degrees of freedom are. Degrees of freedom are always n minus 1. Or in our case, it's going to be 20 minus 1 or 19. And it turns out there's a nifty little chart you can use, which is provided for you on the AP exam, to help you find t star. So here's what the chart looks like. It looks something like this. You have a t distribution on top. You can see it up here. It looks like the normal distribution. And if you look down the side, you'll see a column titled degrees of freedom. Go down a little bit further. We'll find the number 19 degrees of freedom. That's what we're dealing with. We'll go along the bottom of the table, and we'll see 95% confidence. So I'll follow these up. And wherever these intersect, that is your t star. Pretty nice little table to use. I would recommend that. So we can take that. Oh, I forgot what it was. It was 2.093. So we'll go back. We'll put that in here. 2.093. and then we're ready to finally calculate our confidence interval. And depending on how you round, you're going to get numbers like, say, 16.96 up to about 19.9. And that's it. That's how you do a one sample t interval. What we can say in this case is we're 95% confident that the true mean gas mileage of this vehicle is somewhere between the 16.96 and the 19.9 miles per gallon. Be aware, it's another thing could have asked here. They could have gone back to the problem. Let's go back to it and look at it for a minute. Hold on a second. Let's go up here. Sorry. And you'll notice that, let me just use my eraser and get rid of some of this so you can see. They did ask for the 95% confidence interval. If we want, we can get rid of 95% and be asked for other percentages. So maybe you'd be asked for something called a 99% confidence interval, or maybe a 90% confidence interval. And it turns out that they're pretty easy to do. It's the same basic idea. So if they said 99% confidence interval, then everything else stays the same. It's x bar plus or minus t star times s of x over the square root of n. We know that s of x was still that 3.11. This whole thing basically turned out to be about 0.7. Our x bar was 18.43. So plus or minus times something times 0.7. So what you do is, since it's a 99% confidence interval, you go to that chart. You still have the same degrees of freedom of 19, but then you've got to go across to the 99% column. So you go a little bit further here, and you end up with a different t star. In this case, it's 2.861. So that's what would go here, 2.861. If we take the time to calculate that, we get about 16.43 up to 20.43, something like that. Notice this interval is wider than the 95% confidence interval. That's because we're more confident that we're capturing the true mean. And if you want to be more confident you capture the true mean, then your interval needs to be wider. Let's do one more. Suppose we'd ask for a 90% confidence interval. Everything's the same, really. Here you go. But we need to go back to that table now and look in the 90% column. So here it is. There's the 90% column. And if we trace that up to 19 degrees of freedom, it's tough to see there. I know, let me erase a little bit of that purple line. There you are. Now you can see it. It's that 1.729. So that's what's going to go in here, 1.729. And you can tell even before you do the calculation, this new number here is smaller than the previous 2.861. So you know your interval is going to be a little more narrow now. Let's see what we get. Okay, so it looks like 17.22 up to 19.64. So it is indeed a more narrow interval. It's even more narrow than the 95% interval was. And that's because we're less confident that we're capturing the true mean with this confidence interval. Okay, thanks for watching.